All right, welcome back to Ox Tools. I'm Tom. So we got a kind of a little interesting project here. These are some little digital timers that I happen to like. These are pretty nice ones. They're actually laboratory timers, and they're just count down or count up with an alarm. And they're just dog simple, and they use a little watch battery, and they seem to last quite a while. Now, the one thing that goes wrong with them, unfortunately, is this little battery cover gets lost. Okay, this little bit right here, this little battery cover, that gets lost, as you can see, pretty easily. So I don't know, you drop them or whatever, and this thing, disappears, and you can't find it. And okay, so anyway, I lost a couple of them, let's put it that way. So what we're going to do today, this is actually an interesting little machining job. There's some intricacies in here that will make this kind of an informative, interesting machining job. So now I've already got, see, they're even hard to pick up. What it needs is a little tether or something, right? So that it can't get lost. So now I've already done the measuring and whatnot of the one that I still have a cap for. So we're kind of ready to go. So we're going to start over on the lathe, then we're going to go over to the mill and do some stuff on the mill. And it's a small part, so there's some holding challenges, and then we have some interesting indexing to do here, right? And we'll look at two ways to do that indexing. Okay, so let's cruise over to the lathe, and the lathe works is like a couple of minutes, and then we're over to the mill, and we're off and running. So let's go do that. Here's our stock that we're going to use for our little battery cap for that timer. This is ABS, acrylonitrile butadiene styrene. This is actually, it's a pretty good plastic. It's real cheap. McMaster sells it, and it's nice to work with for little projects like this. Now I'm going to leave a little bit hanging out, and the reason for that is that I want some to hang on to for the indexing operation that we're going to do. What's nice about this is it machines real well, and unlike a lot of plastics, this one really cements really well, so you can build up larger structures out of this, which is kind of nice if you have to do that, if you got to glue some pieces together to do something. We're going to use a tool here. This is a high-speed tool, and it's just ground and honed real sharp. I mean, this thing's razor sharp. I could probably shave with that. And we just need two tools here in the lathe. It's actually pretty straightforward. So let's turn this, and then we'll go to the mill. All right, so here's my little chicken sketch of the part. Now, what I want to do for you guys is I'm going to show you kind of two ways to do this. One is I would call it the fancy pants way, where you got a nice piece of tooling like this, right? Which is a real nice way to do this particular thing, because what we have to do is we have to mill and then interpolate and then mill, or mill, and then interpolate, right? And this little Harig fixture works great for that kind of stuff, because you can set stops. You can set a stop here, and you can set a stop here. But this is kind of an expensive piece of kit here, so not everybody's going to have one of these or have access to one. Some of you guys may have it, which is fine. And but what I'm going to do, I'm going to show you a kind of I'm just going to call it a cheapskate way of doing it, using kind of general shop tooling that every shop or every hobby shop should have. And we'll do it with a V-block, okay? And there's a way we can do it with a V-block that's pretty easy, and it'll come out real nice, okay? So I'll show you the setup on the fancy pants one and how we would do it on that, just because it's kind of educational, right? But we're actually going to do the milling with the cheapskate method, if that makes sense. So, okay. And I did a little CAD layout of this because I wanted to measure the angle between the tangent circle here and the tangent circle here that is the end mill diameter that I plan on using. And so it turns out it's I think it's 136 degrees of you know, if you have an end mill here like this and an end mill here like that, and you draw a line to the center there, that's 136 degrees between here and here. Okay, so that's how, I think that's what it is. I gotta go look. I don't know if I remember the number exactly. So, and that looks about right actually. So, all right, so let's, we'll go over to the mill, and actually I need to face the back of that. I'm gonna go face the back of that. I'm not gonna film that, but I'll meet you back at the mill in a minute. So some people, this is a Harig Grind-all #1. Some people call them whirligigs. That's another name for them. They're used in the die making industry to grind ejector pins and things like that, where you have to grind the diameters of them. And it has a little relief in here so that you can put the head of an ejector pin in there and spin that thing. So that's one of the uses of these. But they're just kind of a handy overall kind of grinding fixture, because you can rotate them around, and then it has a lock pin here, and there it's locked up, and you can lock it. It has 15-degree increments, okay, that are very accurate. I think they're I don't know, within a, you know what, I don't remember what they guarantee them for, but they're actually pretty good. And it has this little cool rim here. I'm gonna show that too, where you can mount these sliding stops on here, and then over on the other side there's a pin, so you can go between 2 points, right, very accurately, right? Like if you had to create an oblong punch or something like that, and that's a punch that has straight sides and a full radius and a full radius, right? Where you have a radius and a radius, so you can grind something like that with one of these, which is kind of neat. Okay, but we're just going to kind of use it for basic stuff here, and I'm just going to put the piece in here and just kind of lightly snug it a little bit. We're not going to actually use this for the milling. And then now, okay, so what I want to show you is this is actually centered up for this diameter here now, right? You don't see any eccentricity, but what I want to do is I want to show you how you adjust that, okay? And it's got a little rack and pinion thing here, which is pretty sweet. So you can move the block, right? These things are pretty cool. They're also pretty expensive too, okay? So what you would do is, let's say you put it in like that, and now you see it's lumping around, right? Bloop, bloop, bloop. So what we would do is just kind of by eye, just kind of run it in. See, it's a little less. Okay, a little less. Not bad. Whisker more. Okay, so that's just by eye. Okay, you can see it's actually pretty close. And then what we would do is put Mr. Indicator up here like so. Okay, and then put it against the. Actually, we'll put it against this nice diameter that I turned on there. Am I touching? No, I'm not touching. That. Okay, and then what we can do is rotate this around, and yeah, you can probably see the indicator moving, right? Okay, so okay, too much. Actually, I'm in kind of a crummy spot for indicating there, so. Okay, now I'm screwing up. Actually, let's do this dumbbell. Let's go around this side here. That way we're kind of in line here, right? At least makes my brain work better. Okay. All right, so I need to go that way. All right. A little more. Okay, so I think you get the idea, right? Okay, it's getting better. And then the last little bit, it's hard to do with the rack, right? So what you usually do is just you tap it with a instrument of hammerage and a brass punch or something like that to get that last little bit, right? Okay, but for what we're doing here, this is just a demo, right? That's too much. Right there. Oh, maybe I went past center there. Okay. All right, now I'm getting annoyed here. All right, well, anyway, let's just go with that for now, and because it doesn't matter for what we're doing. And then, so okay, now now we're basically centered up here, okay? And what we would do at this point is now we would sweep this diameter with the actually, you know what? I'm probably a mile off. We would sweep this with the indicator to get it on center of the spindle. Okay, so we're right over the center of that. Okay. Now, but that's not what I want to show you. So what I want to show you is how you set these stops and how we'll mill that. You'll notice that there's two of these things here now, and I learned something myself here. Well, or remembered something. I don't know which. So this was the first one that I was playing with on camera here, and you'll recall I was trying to center this up, and honestly getting a little frustrated because it wouldn't come in. Well, I turned the camera off and I played with it some more, and I couldn't get it in, which was interesting. So, right? So a lot of times the first thing is, hey, why is it doing that, right? So you ask yourself the question, right? So when you find yourself at those junctures, a lot of times it's good to explore them, right? And figure out what actually is going on because you learned something from it. So let me tell you what I did, right? To start with, I said, what is going on with this thing, right? So I moved the clamp around, I reseated it, I fiddled around, no good. So then I pulled out a gauge pin and put that in. I was able to nail that perfectly. So I'm like, okay, it's a problem with the part. So now you look at this is just stock diameter plastic rod, right? So, and you know, it looks relatively round. Well, apparently it's not very straight, so there must be a curve to this thing somehow. And actually, I didn't put a straight edge on it or whatever, but anyway, there's some anomaly in this surface that was causing the trouble. So I said, okay, fine. I got all the tools set up, so I just machined another one. But what I did was I turned this entire diameter down to here, right? So it's freshly cut, it's nice and round, just like what I did here to create a nice indicating spot. I just did the whole surface and then knocked it off. So everything from the tip to the stem there is concentric. And then I was able to dial it in to less than half a thou, okay? So lesson learned, or you know, this is how you figure some of these things out, right? And I figured that was worth sharing with you guys. If you ever have that situation, don't blame your fixture or your technique necessarily. It may be something that you can't see. And when you find yourself at those little, like, why did it do that? Dig a little further, and you might learn something really cool. Okay. So this is the stop pin that I had mentioned earlier. So the shot pin here locks at every 15 degrees. But what we want in this case is we don't want to use the shot pin. What we want to do is we want to swing an arc here, okay, and have positive stops at either end. So what we're doing is we're going from these little corners to these little corners. It's 136 degrees of rotation, okay? So what we're going to do, in fact, it's already set. So you put the pin up here, and you see that stops against there, and that's the, you know, that's an easy one to set. And then it's got a degree scale on this side. We can't quite see it right now, but what you do is you rotate it around. I'm going to push this down for a sec. You rotate it around, and in this case, we can go the 130 degrees on the degree scale and lock in. And then we need to make up that last little 6 degrees, right? And the way you do that is you use a spacer. So this is a known radius. So there's a constant for this this diameter, and you can take the sine of the angle and determine what the spacer is. And in this case, it's this one here, which is 220, 219 and a half or whatever. Okay, so you put that in there, and then you can. Oh, in fact, look at that. The stop is loose. Okay, so we're gonna have to reset it. All right, let me. I gotta now I gotta look at the other side. But anyway, you kind of get the idea there. Is you use this to set the stop, okay, and then you lock the stop down, and now you got a nice hard stop between your rotation, so you can do a consistent grind or consistent milling. So let me reset that little sucker since somebody didn't tighten that up. I wonder who that was. Okay, so we're locked in at 135 or 130, and this what we want is an additional 6 degrees of space there. So we're just going to put that pin in. Let's see, I'm blocking the show there. Let's see if I can, yeah, that's better. I'm trying not to stab myself with that little pesky end mill up there too. Okay. Yeah, you know, you might normally use gauge blocks or something like that, but pins are pretty, you know what, I really want to do it this way, but I also don't want to block your view, guys. All right, let's try that. All right, that worked. Get a little bit more. Oh, what's going on? Okay. I guess it wasn't seated in the groove properly. The intricacies of filming sometimes, you know, really, you know, you don't get to hold the tool exactly how you want, or position your hand the way you want, so that it shows up on, okay, so that's good. Okay, so now let's unlock the shot pin, okay? So now what we're doing is, there's our 0, okay? And we're going to rotate 136 degrees to there, and you see that surface is actually ground so that it has a good reference too, right? Now we don't want to bang that, right, when we come around. We'll just touch it. Same here, touch it. And we can do both sides of that curve in one setup. So since we have 2 of these now, since I bozoed the one and I didn't turn the OD, we'll get to see both indexing methods. So we'll do one on this, and then we'll do one with the cheapskate way, the V-block. Okay? All right, so we're kind of ready to start here. We've got our stop set, we're centered up real nice, all that business. This color of plastic is actually a little hard to look at on video, so what I'm going to do is I'm going to color the top of this. You're going to thank me for this in a minute here, because it's going to make this easier to see, I think. Okay, a nice blue. Nice even coating, okay. So we're going to set the, I'm just going to touch that, set my quill DRO, and let's see, I'll get my numbers in my head here. All right, 230. So we're going to come up to, so yeah, let's just kind of go through it here. We're going to offset in Y, because we're making this little leg, and that's 094. Offset, okay, and then we're going to come up to 230, right about there, okay, and let's see, just dry running, okay, it looks like the end mill's hanging over the edge, so I don't need to take multiple passes here. Okay, so the idea is we'll come up to that spot, then I'll unlock this, and then I'll just swing this through the arc like so, and that's our cut. Okay, in reality, what I'm going to do, in fact, I'm just going to do it now instead of yapping about it, is cut our legs. Yeah, looks pretty good. I'm sure I'm okay here. I'm going up to 230. Right like that. 4. 230. Now we'll come around this side. That's where I got to be a little bit careful. Doesn't look like much, does it? Small parts, you know, it's just not a lot of material removal. Okay, 94. Come up to 230 right there. Unlock. And then we'll just peel that off. So, okay, go back to our starting point. I'm going to go ahead and lock it just because I'm going to come over and we're going to start in this spot on this one. Okay, up to 230 again. All right. And this is real light milling, so kind of no big deal there. Okay, come out of there. All right, I've got some kind of burrs on there. Okay, so there's our little wings. Now we'll do a little measuring, make sure I didn't screw anything up. Okay, yeah, no step on that. All right, I'm pretty happy. Actually, this is just a little bit of steel wool, which works good for deburring kind of soft plastics like this. I'm trying not to kill myself on that end mill, by the way. Yeah, you know what? I think I want something a little coarser than that, I think. About a little bit of gray Scotch-Brite. Oh yeah, that's better. Smooth that out, then I'll take a few measurements and see if I did it okay. Let me turn that so you guys can see it. Hopefully you can. What is that? Oh, I guess that's just a burr. That's dirty. A dirty burr. That's why it's dark. That was a metal chip. All right. We're going to do the second one with the cheapo setup. So this is just stuff that every kind of home or every machine shop or hobby shop should have, right? Is a decent V-block, a vise, you know, some little clamps, right? Things like that, right? Kind of normal tooling, not kind of specialized expensive tooling. Now I'm locking this down. I don't want it to move around because what we're going to do is we're going to use this to guide our part here. Okay, and what we're going to do is we're just going to manually rotate this, but I'll show you how we're going to do that. So first steps here is we're going to clamp this lightly. Okay, 3-point contact, 2 on the V and 1 on the front, super solid. We're going to pick this up, we'll indicate it, get on center, and then we're going to do the same thing we did on the other one, which is cut our little straights. Okay, and then we're going to add a couple features to this that is going to make it easier to do the rest of the work. So let me get centered up on that, and then I'll be right back with you. Okay. Okay, so first off, what we're going to do, get a tool going in here. I'm going to use this big tool here to give us a little bit of help. I'm going to create a couple of reference surfaces for us. Sure, this is kind of snugged up. All right, so we're centered up. So what I'm going to do, actually, I want to come over here. So I'll whack my my V block there. I'm just going to cut some flats that make some sense on here. So 560, sure. We'll do the same over here on this side. So we're going to cut a little, kind of a square feature, not square, but we're just cutting some flats on here, and these will just kind of help us do the work. You know what, I might as well do them on all 4 sides. Why not, right? Okay, so now we've created some flats here. They're centered up on the world. So we're going to use those to help rotate us, and we'll use the other with a little square to kind of help us reorient for the second cut. Okay, let me change tools, and then we'll get ready to do the deal. I'll find a wrench or something that fits that. All right, so we're kind of set up now. So we got our little flats here, and then we're going to just, when we return to 0 here, we're at 0 right now. We'll just use this square to line up on that flat, which I created there, okay? And then I lucked out, it fits a normal wrench size here. We're going to turn this with this. So I'm going to loosen the vise just slightly so that I can turn this with some friction on it. Anyway, that's the general idea. So let's do the same thing we did before and cut our touch off there. I'll 0 up, come on, 0, okay. And then I'll come down to my depth, which was, I think 73 was my number. Yeah, right, oops, come on. Right there, okay. And then we'll move over 094, oops. 094, okay. All right, and well, let's go to town here. Come up to 230. Right there. So we're gonna start over here. Let me clean that off a little bit so you can see what's going on. 194, come up to 230. Alright, you guys ready for this? So same deal here. I'm gonna have to loosen the vise a little bit. There we go. I want to hold down a little bit too. So here, we don't have a hard stop, but we created a nice intersection here, and we'll just come up and get close to it. Like that. Okay, and actually, you know what? I'm going to back off, and then I'm going to come back to 0 here. Okay, and then use my little square, and I think you guys get the general idea here. What? Come on. Oh, actually, I got it. That's pretty amazing. Jeez. Okay, that was pretty amazing. I actually rotated it back by eye to the to the right spot. Unbelievable. Okay. All right, so then we'll do the other side because I know you want to see the other side. Make sure I can do this twice, right? All right, let's do that. Let's do that again. Up to 230. Okay. And we're going to give it a nice smooth rotation. Right into our little pocket there. Like that. Okay. And I think we're done. Let's see if this works here. Yeah, it's got a little fuzz on it. It's not bad. Nothing that a little steel wool won't take off. Okay, so that's the cheapskate method for doing something like that. Okay, so we got a good accurate rotation reference, right? And now you're not going to, hog stainless with a setup like this, but on a little tiny part like this with small tools, the cutting forces are really low, so you can get away with a lot, actually. I'm just using a sharp scalpel here. Okay, and then we're going to use this little vise, and then I'm just gonna orient it with the flats. Okay, and then we'll come in and we'll put with this little key seat cutter here, we're just gonna put a screwdriver slot in that. And now, ideally, the center line of this would be on the center line of that. And let me think about that for a second, how we're going to do that. We're going to use that same technique here to pick up the Z of this key seat cutter. We're just going to come, so the indicator is zeroed on the upper surface of the key seat cutter, which is pretty thin, so it'll deflect pretty easily like that. You see the indicator moving? Okay, I'm just barely touching it. I can't really feel it. Well, yeah, I guess I can a little bit. But this is right there is going to be a pretty good pickup. Let me zero that quill. Let's double check that. Yeah, so I like that. All right, and then I'm going to come off of the part. I'm going to come down below the surface half the cutter diameter, which is 16, I think. Yeah, right there. All right, let me zero that again, dink, okay. So now, the center line of the cut, oop, don't knock this up, dopey. All right, yeah, just lower that while I yap here. I'll just take that off. And then I'll lower that halfway, then I get my slot in the center there, so. Okay, so we're on the center line. And so the next thing is to pick up the Y direction. And now, it's just a screwdriver slot, so, you know, I could probably just eyeball it, but you know how much I hate that kind of stuff, right? If you don't have to eyeball something, why eyeball something, right? So I think what I'm going to do, I'm going to come up, and I'm just going to come to a midpoint there. And actually, you know what? I'm going to come on the other side here. That way I can see what I'm doing here easily. And I'm just going to use the little paper trick here, like this. Come up, get the paper in there, and just inch in until this grabs the paper. Okay. Oop. All right. Now I'm going to zero. Okay. Now, it didn't touch the part. All it did was touch the paper, right? So I'm going to come over here. Try not to saw it in half. Come up to the same spot in X. That way the thing hits it at the same angle. And then I'm going to do the same thing over here. I'm trying not to hit the dang camera there. And then okay, and now I'm going to use the split function of the DRO. Okay, so I'll come back out here to 0, and it should be pretty close to the center line of the part. Okay, and then to make the depth the same on these, I think I'm just going to do a witness mark and then plunge in. And actually, you know what? Better yet, let's do this. We'll just do the same thing, because that's 3 thou. If I can't reach the dang okay, and 0 that. Okay, so I'm pretty happy. I don't know. How deep should I go? Let's go in. Let's go in 40 thou. Let's see what that looks like. That, you know, I'm gonna go a little farther. I'm gonna go 50. Just cause. You know what? I'm gonna go 60. 16. Okay, there's our number. Oh yeah. All right, let's pull it out. Looks like a screwdriver slot to me. All right, I'll do the next one, and then we'll do a final fit up. So this little lug here that we created, for it to work properly in this slot, it needs a little lead in on the edge. So what I'm going to do is I'm just going to trim it with a scalpel here to thin this leading edge, like that. Actually, that's probably enough there. And it's the same on both sides there. Hopefully you guys can see this. So what I'm doing is I'm just creating a little ramp here, like that. Taking a little triangle out of that thing. There we go. So see, it's got a little angle now. So theoretically, that should work now. See, now you see why these things get lost, right? All right, I might need a little more. Where's the, I don't know, that's the stop point, huh? I don't know, I guess it was okay. It just felt like didn't quite feel like a, come on. There we go. Okay, now that's it. All right, let me get the battery. I'll stick the battery in there. That's really the test, because the display comes on when you put the battery in, so. Okay. Okay. All right, so. So yeah, these are pretty cool, the way these work. And then you can reset, or you can just start it like that, and then it starts counting, and then stop it. So you can time or count down, which is kind of a, hello? Oh, this is what happens when you try to read upside down. Hit the stop button, dimwit. There you go. All right, well, there's a cap, or a battery cap, and then I got a second one here that I gotta trim the ears on. Anyway, thanks for watching.